Well, you know what we who we are and where we are. We are on Odikeo. And today we are going to see safety net. This is the hashtag, so any retweet, tweet, wherever would be appreciated. We have to say thanks to Andrés and team of Odikeo for this event. So well, today we have a continuation of the past talk from Christoph, security tips for Android development. And well, here is Christoph. Oh.
Hello, I'm Christoph. In English is Christopher, in Spanish is Cristobal. This is my second talk. I'm an Android developer from 2009. I currently work in my taxi, and today I will be speaking about Android app verification. It's the second talk, but if you weren't on the first one, we are not really missing anything because it's like the single part. But I will cover something from the previous talk. So for the previous talk, we learned that application code can be modified. So whenever you have your app published on a Google Play Store, then someone can grab this app and modify it. But we also learned that whenever someone takes the application and modifies the code inside, he or she needs to sign it with some kind of certificate. And we have our own certificate that should remain private, and it's stored in the key store. Our key store that is like essential to publish something on Google Play. And whenever someone modifies something, he needs to sign it, sign the modified app, and the fingerprint of the certificate will be different. So this can so we can distinguish whether something changed. Also, there are on Google Play there are some applications that streamline this. There is application called App Cloner, and with this application, an user can create any clone of existing Android app. And what this application does behind the scenes, it just grabs the APK, changes some identifiers like Android ID or things like that, changes the package name, resigns the application, and put it back on user's device. So user has ability to clone your app and use some and use it as different app. So basically, if you have if you want to prevent that, you need to employ some verification. So as I mentioned before, we need to provide some way to verify our app. So we need to use here. The solution would be to use a backend. It can be like our own backend server, or it can be a Google backend. And I will show you three solutions. First would be Google sign-in. Second would be push notifications. And the third one would be safety net. So let's start with the first one. We can use Google sign-in mechanism to obtain the token from Google backend, and then verify this token on our backend. So first, we need to create an API key in a console, like API console that you might be aware of. And then, if we created this key, we need to limit it to our package name and our certificate. So after we do that, we provide some sign-in experience, like we provide a button to sign up with Google, and once the user of our app is sign in, then we some token, and this token we send to our backend, and on our backend we can verify whether this token was correctly signed by our app. So we verify this token on our backend, for instance, using Google API Client Library, and then what is advantage of such solution? If someone takes your application, changes something, then if we have some logic in place that is using Google sign-in and verifies the token on our backend, he needs to provide his own API key. When he provides his own API key, then the ID token will be different, and this token won't pass verification on our backend. But this solution has some disadvantages, because we need to use a Google sign-in mechanism in our app, which might not be the case, because maybe we have some application that doesn't require logging, or we don't want to use Google sign-in at all. And also, this solution can prevent rooting, even though we protect our app, and even the attacker won't change the app, he can modify the underlying system, underlying API. For instance, he can spoof some API calls from the system to provide fake information to our app, like what is the certificate that we were signed. And when there are, for instance, there is a exposed framework. I don't know how many of you have heard of it. Some of you. So basically, when you have a rooted phone, there is a kind of a framework that you can provide some mechanism to inject some calls, and this exposed framework can be used, for instance, for bypassing secure connection, SSL pinning, for instance. So even though you are using some methods to verify your app, if you have like the system that is compromised, you are unsafe in this approach. Then we can use push notifications. You might wonder why we should use push notification for protecting our app, but I will reveal this in a moment. So the setup procedure is basically the same. We create an API key, like in a Google console, for push notifications, and then we provide some endpoint on our backend. Like, let's say that it's a login endpoint, and then when we have an app and we call this login endpoint with our user credentials, then we just return 200 OK from the backend and send our authentication token for the user in a push notification. So the flow looks like that. We have a mobile app, we have a Google backend, and we have our own backend, and the app calls login to our backend. Then on our backend, we just return 200 OK with no body. What happens next? Our backend sent a token in a push notification to Google Cloud, and then Google Cloud sends the token back to our mobile app. By doing this, we are relying on the fact that whenever someone will modify the app, then we have a key that is limited to a specific certificate that was used to sign our app. And if he wants to, he won't be able to log in, basically, because the API key should be different, because this API key relies on the certificate. But also there are several disadvantages of such solution. The first one, most obvious, that push is not so reliable. So even if you implement such flow, you might expect that 1 or 2% of users won't be able to log in, because we are relying on push notification that it can take like several seconds to log in, or the push can be just lost somewhere. And also, this method of protecting your app can't protect against routing. So as you can see, phone routing can bypass almost all security protections, and Google was aware of that fact, and they invented. Basically, they bought a company that was doing a thing called safety net, and this safety net attestation API, basically, it does two things. First, it checks if the device conforms the CTS, and the second thing this safety net does is checks whether the calling app is legitimate. So you might wonder, what the fuck is a CTS? So CTS, how many of you know what the CTS is?
It's a whitelist devices.
Three?
A whitelist of devices.
It stands for compatibility test suite, and this test is performed for every single device that Google puts on the market. So whenever, consider you are a device manufacturer, you want to put a new model of Android phone onto the market. So you go to Google and you say, okay, Google, I want to have like this device, and Google says, okay, please provide me the device, and we will check whether this device conforms our test. And this test checks the whole API of the system, so we developers can rely on different models of the devices, because the API across the devices is consistent. And this test also checks whether the device conforms some requirements imposed by Google. So what the safety net is doing, it is checking whether the device is matching the profile of the verified device in CTS. I will show you how it looks like in the test, but this is later. And what is Pokemon Go doing here, you might ask? And the answer is that after introducing this mechanism, Google thought that it must check how it works, and they put the safety net checks in Pokemon Go to check how easily people would be able to break it, and how easily or how hard the safety net is being able to break. And after that, they put it to Android Pay. So when you are using Android Pay, the safety net is checking whether the device is safe enough for Android Pay to work on that device. So I will show you the whole flow, the secure flow that should be implemented in order to use safety net. So we have Google services that might be, and by Google services I mean thing that is on the user phone, but also some Google infrastructure, some backend. So here is like user device and also some backend. We have like our mobile app, our code base here, and we have our own backend. What we need to do? We have a mobile app, and this mobile app request sends a request to our backend for a nonce, and this nonce is this hard term. For me, it was like also not so obvious. So this nonce is a unique temporary identifier that should be generated on our backend. So we are requesting this identifier and providing our backend with, for instance, some username of the application and device ID. So our backend generates this nonce that should be unique and stores it in some temporary cache. And this nonce is assigned to user and device ID here. Then the nonce is sent back to mobile app, and our mobile app, using some Play Services API, takes this nonce and requests attestation. Attestation means that we want Google services to check our device whether it's passing the CTS test, and by passing CTS, it means that this device is not rooted, because no rooted device will ever pass CTS, because Google doesn't want rooted device for some like crucial solutions like banking. So we as mobile app, we call to Google services, and what's happened there? Google services downloads some binary from Google server, and this binary performs checks on user device whether the device was modified somehow, whether the bootloader, if there's some files indicating that device can be rooted, and then some hash is computed and sent to Google backend to check whether this signature matches some database of verified phones, and then there is a result from Google services sent in JWT. This is another hard term. This slice is a token that is digitally signed. So you have a token that you cannot modify, and more on that later. And we have the token in our mobile app, and then we pass it to our backend. And in our backend, we verify that token, we do some verification, and inside this token, the nonce from the beginning it is inside this token. So if we check this nonce, we should remove this nonce from temporary cache. So nobody can replay this part of the graph. So what is this token? It looks like that. And it consists a certificate and a payload. And here you can see that we have some nonce, that this is this unique identifier that we request from the backend. In the first place, we have the timestamp, package name. We have the timestamp, package name, the digest of the APK, the whole APK, the whole file. We have the digest of the certificate, and we have two Boolean flags, basic integrity and the CTS profile match. And if we want to verify whether this device is valid, we need to check that those two flags are true. If they are, we are sure that this device is not rooted and there is no bootloader, unload, and so on. Also, we can check that the APK wasn't modified, even if we are like super obsessed on the security. We can check even the digest of the whole APK. So, but this can be like kind of tricky, because storing like every single digest of every single APK, if you have like nightly builds or things like that, can be tricky. That's why I just omitted it, and I think that checking the nonce, package name, certificate digest, and profile match and basic integrity should be enough. So how? Let's say that we want to implement this solution in our app. How we should set up? First, we should obtain an API key from Google Console, but important thing that we cannot limit this to our application. Why? Because, as I mentioned before, there is a binary that gets downloaded, and this binary performs some checks. And this binary is in a different process from our application, so we cannot limit the API key to our application, because it won't be our application that will communicate with Google services. That's why we shouldn't limit the API key. Unfortunately, it's not explained in the documentation by Google, so you might get surprised. You generate the key, you're limited because you want to be safer, but it doesn't work like that, unfortunately. Then we need to prepare some backend endpoints, at least two. So first one would be endpoint to provide us with a nonce, and this nonce we need to identify the user. So it would be nice to provide some like username and device ID. Then we need to provide another endpoint in which we will send the JWT token. And the good candidate is a login endpoint, because in the login endpoint we can provide the username, password, but also this token, and verify all the things all together. Verify whether user can have like valid username and password, but also if he or she has valid device. And there is another two like hard terms in Google terminology. This token I I was talking about, it can be verified offline and online way. And Google distinguishes those two ways, but offline by them means that we are validating the token entirely on our backend. So we got the token and we validating it entirely using some libraries provided by Google on our backend. So how this validation look like? We get this this token. We parse this JSON with signature. Then we verify the signature. We retrieve the certificate, and then we verify the hostname. And the hostname should be something like Google something. It's explained in the sample project. And then when we verify the hostname of the certificate, then we can extract and use of the payload data I showed you before. And they also provided, I don't know why, thing that is called online verification. So basically, you can get the token on your backend, and you can send it to Google service for verification whether this token is correct. But it doesn't do any verification of the payload. It just verifies the whether the token is valid itself. And even Google is not recommending this solution because it will consume some calls from your Google console, and it's slow because you are apart from sending from mobile device to backend, you are also from sending it from your backend to Google infrastructure. And I showed you like the secure flow that you have like two endpoints. You are getting the token. You are sending it to backend. Some people might consider, I don't have a backend. Maybe I will get the token and I will check this token inside my application. And we know that this is bad because if we will be validating and checking the content of the token inside our application, someone can just grab our application from Google Play and just remove this whole verification logic, and we as app developers, we won't even notice. So this is like a very basic mistake. But there is another mistake. Even though the token is verified on the backend, there would be some Boolean flag returned to the app, and it will look like that. If we have like valid response from the backend, then do some logic. I don't know, log in the user or proceed with the payment or whatever. And this is also like kind of huge mistake because also someone can just remove this if, saying that it's always true, and even though we have some whole infrastructure for like verification, it won't work. So I prepared some frequently asked questions because I did this talk before, and people were having some doubts, and I grouped some questions and answers there. So, can token be modified? No, because it's signed, it has some certificate, and you aren't able to modify this token. So the second most common thing was, can traffic be replayed? So we don't we have this token, we cannot modify this token, so maybe we can just record the network traffic and just replay that. Or maybe we can grab the nonce and try to query the Google services and send the token back to our backend. But if we implement on our backend the nonce that it is unique per request, and after the verification it gets removed from our cache, then we should be safe. And then the last question: can those checks be bypassed? There is some binary that is downloaded on the phone. There are some checks performed, and can some routers bypass those checks? And the answer is yes, they can. But given the fact that the binary is re-downloaded, so even though our code of our app doesn't change in time, the binary that is downloaded can change, and Google can improve this binary to detect new routing methods. So this whole safety net moves like our responsibility of app developers for detecting root onto Google. So whenever someone will invent some new routing method, Google can fight with that. So it looks like that. On this picture, on this animation, you might wonder, where are Google and where are the routers? Who is who? And for nowadays, the answer is that this is Google, and those are the routers. Why? Because some clever people out there, they invented a routing mechanism called systemless root, and this systemless root doesn't modify the system partition of the phone. So this tool is called Magisk, and this is logo of this toolkit. So using this routing method, the safety net check passes. And the problem is that the safety net is running with the normal user privileges on the system, whereas the root mechanism is like underneath. So it's so the safety net is unable to detect this. And even though the safety net was updated to check some system properties that were left by this tool, this guy, after he just changed those system properties to some other values. He started to hide them somewhere, and for now, safety net is passing on those devices. So basically, if you are using such technique, you can use Android Pie and you can use Pokemon Go. So disadvantages can be bypassed, and for now it is bypassed. And the second thing, you remember that I told you that you shouldn't be limiting the API keys. So when someone wants to attack your app, he can use the online verification, token verification method with your API key, and he can send multiple requests to deplete your key limits. And the fun fact is that this online verification method and the attestation checks are using the same pool of the request. So whenever this pool will be empty, we won't be able to perform safety net attestation on the device. I don't, and unfortunately, it wasn't like that, because in the first version of the safety net, the API key wasn't required, and they updated the safety net mechanism. I think it was around the Google I/O or something, and they now are requiring this API key. So disadvantages are things that they are like now. Maybe Google will invent a method to fight this systemless routing. And the second thing is that this API key also can be fixed by Google in future. But not to left you with some like bad news, I prepared some special bonuses. And the good thing is that the safety net is not only one API. There is a whole family of APIs that you can use. There's more. So in the safety net family, there is a thing called Safe Browsing API, which detects whether the URL you are dealing with is marked as threat by Google. So if you have like this Chrome browser on your desktop and you enter some URL and you see like large red screen, you can use this mechanism as an API in your app. So whenever you would be dealing with URLs, you can use that thing. Then Google provide reCAPTCHA API for mobile. So if you have some application that doesn't require to have a user, then you might consider using this reCAPTCHA API to prevent some malicious usage. And the last safety net API is a Verify Apps API that Google is pushing around. You can see it in Google Play that all your apps are safe and so on. And you can use this also as an API, and you can get the list of like harmful apps that are on the user device. So that's it for all. I mean, it was a positive talk. Sorry, but maybe there are some questions.
You said that one of the verifications is check if the device is CTS conformant. On the emulator, so emulators used to not be CTS conformant until the very last ones, which are the ones that are able to use Google Play.
I think that they are still not, even though they are having a Google Play installed, they are not conformant.
They are because one of in the Backstage podcast, do you know it?
No.
It's a podcast done by Googlers about things that are kind of internal in Android and Android development tools, etc. And one of the things they said is in order to be able to use Google Play, they had to be CTS conformant.
Yeah. So
I don't really know the technical reason, but
those emulators they don't have ability, because in the past when you had an emulator, you were having a root on that emulator, and now you don't have root when you choose emulator that have Play services installed.
Yeah. So well, my question was, are you able to use this safety net on those older emulators, or it's
No.
the back version or something?
those checks will be false. I mean, when you are using the emulator that has like basic root, those would be false.
So then you have to build a debug build without those checks and
Yes.
release build the checks.
Exactly.
So there is basically no way to verify
I mean, when someone deliberately wants to root the device, then and if he is using Magisk framework, then no. But if we have like lots of users that have some like I don't know malicious app that rooted their phone, then probably this can be helpful to check whether the device is rooted or not. You must remember that those like there are several different routing techniques. So some people are using expose framework, and if someone is using this framework and did some like that, let's call it traditional routing, it will be detected. But this Magisk was primarily targeting against the safety, and for now, it's succeeded.
But in my experience, I mean, I have an old phone that is rooted because it's so old that it was not supported. One has with Magisk was never able to bypass safety. Even though Magisk was updated like every 4 days. Every 4 days you get an update. It was version 13 point something already. It was never able to bypass safety. I don't know why, but
also the author of the Magisk, he says that it works in some cases, but also there are like two cases. One case is that you can have a rooted phone, obviously, but if you have like some unknown manufacturer Chinese phone that has never passed the CTS, then this will be also indicated by safety net. So if the device wasn't certified by Google, then
well, it was a Samsung S3. I never really went into details, but it was some wrong. I don't know.
yeah. Even like the newest phone models, some of them, even though like the Magisk is updated, they don't pass, and it varies from model to model.
Have you ever seen this captcha API implemented in real production application?
To be honest, no, I haven't seen it. I've seen some demo from.
I've seen demos too, and they've got like big production, Google developers box and block, but I've never seen like any application like which would use it. Like I think the users are not used to use this captcha at the moment.
Maybe this might be one indicator, and the second one that this API is not so popular. So maybe the app developers aren't aware of that API. Actually, like I showed like the three ways to bypass, and like from my experience, like I was using the first solution about 2014 because at the time there wasn't a safety net, so we were implementing this Google sign-in mechanism, and it worked quite well. And then, like I used the safety net, let's call it version 1, and but we weren't blocking the users. on our backend. We were only collecting this information. So we collected the logins and the results of the safety net check in order to provide some security department information, whether the user that has rooted phone is more prone to some like account theft or things like that. So basically, what you can do that information on your backend is up to you. You can block the user, but you can passively just collect the information how many users have rooted for phones, for instance.
And the second option that you showed, the one about returning the access token through a push token, through a push notification, sorry, is that a workaround that you thought about, or is it someone recommended? Yeah. I was thinking, is this something that you came up with, or is something that you've seen someone recommend? Or
no, this was like the workaround because we in our company we were thinking about ways even before like the safety net was introduced, about some creative way to protect against app modification. So we wanted like to provide some ways, and this is like very custom solution that never gone into production, but it's kind of idea how to use this API key that is limited to your specific certificate that you are signing your app. Actually, similar to the first solution. Basically, the first solution, this Google sign-in with this ID token, Google actually took some of the implementation details of this solution and made it to safety net. Basically, this ID token is is like the same kind of token that is being sent by safety net. So they just have some experience and they the technology.
So to use safety net, you need to use Google Play Service.
Exactly.
What if on a rooted device you were able to modify them?
So if the Google Play services will be modified, you need somehow to get the token, and the token itself contains the unique identifier you got from the backend. So even though you somehow modify the Google Play services, this token is not generated on the user device. It's generated on Google backend. So it might be possible, but it will be tough to modify. And also, if you like the whole architecture of the safety net was designed to prevent such cases. So if they would find out that something like that is happening, they would be able to update this binary that gets downloaded to user device. So that's why Google Play Services is like tiny wrapper for like downloader of the binary that performs the checks. Any more questions? Yes?
I have a last one. Since you know that they used it in Google Play, has there been any case that Google Pay has Google Pay been hacked? Like, is there any known case where?
I don't know if the Google Play was hacked, but if you are like, if you succeeded to root your phone with a magnet, then it's possible to use Google Pay even though you have like rooted phone. But I haven't heard of any cases that Google Pay itself was hacked.